Hi dear students, in this video now we are going to learn the preparation and properties of the benzofuran. In benzofuran, two rings are there. One is the benzene ring and the second ring is the furan ring. These two rings are fused here. First of all, we discuss about the Perkin's method for the synthesis of the benzofuran. In Perkin's synthesis, starting substance is coumarin. Coumarin structure is like this. So here one double bond is there and it is a cyclic ester. So we can say that coumarin is a unsaturated cyclic ester. Cyclic esters are generally called as the lactones. So it is an unsaturated cyclic ester. It is treated with the bromine in the first step. As one double bond is present in the coumarin, it undergoes the addition reaction with the bromine and we get a addition product like this. So here one bromine is substituted and one more bromine is substituted here. So this is the addition product obtained from the coumarin on treatment with the bromine. Then this addition product is treated with the NaOH base. NaOH is a alkali or base. In the presence of this base, this ester undergoes hydrolysis and this ester bond breaks and it changes into hydroxy and carboxylic acid groups like this. Here we get the hydroxy group. One bromine is present here and the second bromine is present here, and here we get the carboxylic acid group. As it is still in the presence of the alkali, this one loses the one HBr and we get unsaturated carboxylic acid, which is known as the cinnamic acid. So look here, in the presence of this NaOH, it loses the HBr and we get the unsaturated carboxylic acid like this. So look here, one H from here and one bromine for here goes outside like this. Okay. Here we are having one bromine. So this is nothing but bromocinnamic acid and one hydroxy group is present here. So we can call it as the orthohydroxy bromocinnamic acid. Okay. Then this one undergoes cyclization due to the presence of the electron pairs on the oxygen atom. It undergoes cyclization and we get a cyclic product like this. Here HBr goes outside. First of all, bromine goes outside and oxygen gets the positive charge. Then after this hydrogen leaves that oxygen atom, as a result we get this one. We can call it as the benzofuran 2 carboxylic acid. Benzofuran 2 carboxylic acid. This benzofuran 2 carboxylic acid on heating loses the carbon dioxide molecule and we get the what is that, benzofuran. Like this. So this is about the Perkin's reaction. So in Perkin's reaction, first of all we take the coumarin. It is treated with bromine. We get addition product. Then this addition product is treated with the alkali. Then HBr goes outside and we get the cinnamic acid product. This one undergoes cyclization and we get the benzofuran 2 carboxylic acid, which on further heating loses the carbon dioxide molecule and gives us the benzofuran. We go for the second preparation method of the benzofuran, that is the internal Claisen condensation. Claisen condensation is a condensation of the two ester molecules. So here the starting substance used in the uh, internal Claisen condensation reaction is hydroxy salicylate. So ethyl orthohydroxy salicylate. So this is the starting substance used in the internal Claisen condensation. And second metal is the ethyl bromoacetate. So look here, this is the uh, bromoacetate. So look here, this is the bromoacetate. We have to put minus. But here I write the ethyl group. So now it becomes the ethyl bromoacetate. So this one is the ethyl bromoacetate. So this is the second starting substance. So here we use the two reactants. This one is the what is that? Ethyl salicylate. So this one is the ethyl salicylate. Orthohydroxybenzoic acid is known as the salicylic acid. No? So the name of this compound is ethyl salicylate. Ethyl salicylate. So these two are the starting substances, ethyl salicylate and ethyl bromoacetate. In the presence of the base, a strong base like sodium ethoxide, NaOET, ethyl group, oxygen and sodium. So it is known as the sodium ethoxide. It is a strong base. In the presence of this strong base, what happens? HBr goes outside, hydrogen and bromine. HBr goes outside in the presence as the HBr, and we get a substituted product which has the two ester groups in it. So look here, CH2, COOET, and one more ester group is here. So now in this compound, two ester groups are there, first ester group and second ester group. And in this ester group, one methylene group is there adjacent to the carbonyl group of the ester. So now this shows the acidic nature. So in the presence of the strong base like sodium ethoxide, one hydrogen will be abstracted from here and it will become as the carbon ion. So look here. So now look here, like this we get the carbon ion. Now this carbon ion attacks here and this one gets the this oxygen gets the negative charge here and the cyclization takes place. Now this electron pair comes here again and this ethoxy group outside easily. Ethoxy group is a easily leaving group. So this ethoxy group goes outside. Ethoxy group and look here, we get the double bond O here, COOET. So this one on further hydrolysis, either in the presence of acid or in the presence of base, undergoes hydrolysis and we get the carboxylic acid group. So here we get the carboxylic acid group. This carboxylic acid on heating loses the carbon dioxide molecule. And here we get the hydrogen. So already one hydrogen is there, so on losing of the carbon dioxide we get one more hydrogen, that means two hydrogens, but I am writing here only one hydrogen. Now this one undergoes the tautomerism, that means keto-enol tautomerism, and as a result we get the hydroxy benzofuran. So look here, here we get the hydroxy group. So 1, 2, 3, 3 hydroxy benzofuran. So in this method we are getting the substituted benzofuran, that is the 3 hydroxy benzofuran. Now we go for the third preparation method of the benzofuran, that is by using the phenol. We know very well the formula of the phenol, that is the C6H5OH. So this is the one starting material, and the other starting material is this one. So this is the derivative of the aldehyde, and it is the bromoacetaldehyde. This aldehyde is bromoacetaldehyde, and here two alkoxy groups are there, no? So such compound is known as the acetal. So it is known as the bromoacetaldehyde diethyl acetal. So it is known as the bromoacetaldehyde diethyl acetal. And this one is the phenol. Okay, so this phenol easily undergoes substitution with this one, and bromine and H goes outside in the form of the HBr, and as a result we get a substituted product like this, OET, and here we are having one more ethoxy group. So this substituted product on treatment with the anhydrous zinc chloride and first of all undergoes cyclization. So look here, and we know very well that ethoxy group is a easily leaving group, no? So that's why this one undergoes cyclization, and we get a product like this. And in the next step, this one loses the ethyl alcohol in the presence of the anhydrous zinc chloride, and we get the benzofuran. Now we discuss about the properties of the benzofuran. In benzofuran, 6 atoms are there in the benzene ring and 3 atoms are there in the furan ring. That means the total number of atoms in the benzofuran is 9, whereas the number of the 5 electrons is 10. Here in benzene ring we are having the 6 electrons, and in the furan ring we are having the 4 electrons. So that's why the number of electrons is 10 in the benzofuran. Here the number of the electron is more than the number of the atoms in the cycle. So that's why we can say benzofuran is more reactive towards to the electrophilic substitution reactions than the benzene. That means it is more reactive than the benzene. And again, in between these two rings, that means in the benzene and in the furan ring, furan is more susceptible towards to the electrophilic substitution reactions, because here furan is electron rich compared to the benzene ring. So that's why in a benzofuran electrophilic substitution takes place in the furan ring. Again, we have to understand at which position the electrophile attacks on the benzofuran, either on the alpha position or on the beta position. That we have to understand. That can be easily understood by writing the resonance structures for the electrophilic substitution of the benzofuran. So look here, when electrophile attacks on the alpha position, here what is that? Positive charge appears on the oxygen of the benzofuran in the third structure. That means 3 structures are possible for the benzofuran when electrophile attacks on the alpha position. But when electrophile attacks on the beta position, oxygen gets the positive charge in the second structure itself. That means it easily loses its aromaticity. So we can say that electrophile attacks on the what is that alpha position in the benzofuran. Now we go for the example for the electrophilic substitution reactions of the benzofuran. Now this is nitration. So we know very well that HNO3 and H2SO4 mixture is known as nitration mixture. So when benzofuran is treated with the nitration mixture, we get the 2-nitro-benzofuran. And when it is treated with the sulfuric acid, sulfonation takes place and we get the benzofuran 2-sulfonic acid. Benzofuran 2-sulfonic acid. This is benzofuran as 2-nitro-benzofuran. And when it is treated with the methyl chloride that means alkyl halide in the presence of aluminum chloride, Friedel-Crafts alkylation takes place and we get the 2-methyl benzofuran. And when it is treated with the acetic acid anhydride in the presence of aluminum chloride, Friedel-Crafts acetylation takes place and we get the 2-acetyl benzofuran. And when benzofuran is treated with the ozone in the presence of zinc, that means ozonolysis takes place, and we know very well that ozonolysis is a one type of oxidation. No? So in the oxidation of the benzofuran with the ozone, we get the salicylaldehyde as well as the salicylic acid. Salicylaldehyde and salicylic acid. And when benzofuran is treated with the peracid, that means peroxycarboxylic acid, we get the epoxide like this. So these two are example for the oxidation reactions. And when benzofuran is reduced with the sodium ethyl alcohol, we get the 2,3-dihydrobenzofuran. So it is a example for the reduction. In the similar way, when benzofuran is reduced with the hydrogen in the presence of nickel catalyst, we get the perhydrobenzofuran. That means here all double bonds are converted into the single bond. So that's why it is known as the perhydrobenzofuran. And when it is treated with the chlorine in the presence of alcoholic H, we get the alpha chloro 2 benzofuran as well as the beta chloro benzofuran. So there is a possibility for the formation of two types of products here.